Right, hi. So I've been very interested in passkeys for a little while now. Finally got around to implementing them, and I did so with zero client-side dependencies and using server-side rendering with the stack that I showed in an earlier video. But for those who don't know, passkeys are a newish way to authenticate, and they do so without a password at all. The sensitive information is stored directly on the user's device or in their password manager, and there's no sensitive data stored on the server. Whenever you register or you need to log in, you just authenticate with your device, whether that's a fingerprint or Face ID, and that's used to authorize you. There's no sensitive data stored on the server, and that's what makes them really good. I have a quick demo of a website that I built just to learn how to use passkeys. And what I can do is I can register, and when I register, I just provide a username. I don't provide any password. And I click register, and then this will be saved in my Google Password Manager. I say that's okay, and then I authenticate, and then successfully registered. Now I can sign in, I think it's this one, and the server returns a valid JWT for me to use for future requests. But just to show it doesn't always work if I have one with invalid credentials here, and there we go, and that failed. So what's going on here? I'll just do a brief overview of authentication and how passkeys work. So we have a browser and we have a server. And the age-old problem in authentication is that you can't really trust the browser. So we're trying to verify that these requests can be trusted, and we have to be very wary of everything the browser does. How we usually handle this is that the user, talking to the browser, supplies a password. And then maybe in a very primitive way, you would store the password on the server. And then the next time they want to log in, they just provide a password and you just check that it matches. But now generally we don't need to store the password on the server, we just hash the password, because hashing of the same word will always return the same hash, but you can't go from the hash back to the password, so it's much safer to store on the server. And we actually salt the we hash and salt the password just to make it a little bit safer, but we're still storing sensitive data on the server since some version of a password, some version of a private key is being stored on the server, so that's not great. But dealing with passwords is a huge pain, and a solution to that problem is to use OAuth. So instead of trusting the user and having them provide their password, OAuth has a third-party service like sign in with Facebook or sign in with Apple, sign in with Google, and instead when the server wants to authenticate you, they'll get the browser to authenticate with this third-party service, and the third-party service will inform your server of the credentials, and then you can give the user a valid session. So this is great because you don't have to store sensitive data on your server, and it's definitely more secure. There's less burden on the user to remember all their passwords, so you can just sign in with this. There are downsides though, so you're depending on a third party now, so you have to follow their rules and be happy with them, and you have to be happy with the data they're keeping and what they're sharing about your users. You have a single point of failure as the user. If this account gets hacked, they can access all those accounts. There's also phishing attacks where someone can pretend to be this third party, and also in a lot of cases you can't create multiple accounts for the same server because the user just has one account with this third party, so that's what they use to create the account with you. But it is much better, and Passkeys is a further extension of this. So instead of depending on a third party, you say that you trust the user's device. And in Passkeys, the user's device will create a public key and a private key. The summary of private key, public key, you create both a private key and a public key, and the private key can be used to encrypt data, and then you can share your public key, and when you sign something with your private key, the public key can be used to determine whether that signature is correct to the public key that's stored. And why that's useful is because now we don't store any sensitive data on the server. All the sensitive data is on the user device, which is the private key. In Passkeys, the device creates a public key and a private key, and then the public key is passed to the server, so the server stores the public key. And when you want to sign in, the browser asks the device to encrypt some data, and then that data is returned, and the server verifies that it is encrypted with the correct private key. And this can't be spoofed by the browser. And so that's how this demo works. When you register, it'll save the public key in the server, and then when I sign in, it'll check that public key was correctly encrypted. How does this work in practice? There's a few APIs, they're not all stable. It all comes from this credentials container. You get create, which lets you create a new private key, public key with authentication. And there's get, which lets you verify the key using a signature. And out of these, there's a few reasons why the API is a bit frustrating to work with. The main one I encountered was that everything is stored as byte arrays, and that everything to convert to JSON is still experimental, so it couldn't be used in anything except Firefox. When you're using this create function, and I'll show this in a second, you get back this object, and you can call get public key algorithm, and get authenticated data, and that's all the data you need for registration. And And the reason I mention this is because if you try and access the fields directly, you have to decode them with CBOR, which is super annoying and it's hard to send them over the wire. So just use these functions directly. I didn't end up needing to use the get transports. And then when you verify, you can use the get function. And the get function will return you the signature, the user handle, and the authenticated data. So this is the data that was signed, and this is the signature. So you verify that using the public key stored on the server. Let me do a quick demo of how that works. This is my server. It just returns HTML. It's in a bit of a weird format. If you're not used to it, have a look at the HTMX video I did. But basically, this is my registration page. And in my JavaScript, I just have a single JavaScript file that lets me add HTMX-like attributes. And I have these for Passkey. So this is my registration page, and these are the two buttons you see. And I just provide this data for client. This tells it which URL I want it to hit, the challenge, the name of my provider, the host of my provider. So this has to be whatever website name would be. This is what it is. And the user ID that the user will have. And then same on login, I just provide the URL and the challenge because that's all it needs. And then we'll look at the client-side JavaScript soon. It's very small, only about 100 lines of code. But once the JavaScript runs, for registration, it will create a public key, private key pair, and it will return to me the data in this function. Yeah. So it returns to me client-side JSON, which is kind of confusing because it's within JSON. The whole encryption here is really confusing. There's some things encoded as plain string, some things encoded in JSON, some things encoded as CBOR, and you have to know which ones to grab. Before registration, you just need to grab the public key and the public key algorithm from the response and the client data JSON. This is used for extra validation, although I'm not using it here. This provides things like the challenge and the information about the client. But if you grab the public key and the public key algorithm from the response, and then you can provide your username and your user ID, just save that to a database and you're good for registration. And then for authentication, or you get given the same client data JSON, you also get authenticated data and the signature. And I just provide this. This is the user ID as saved in the password manager. And what you're going to do is you're going to take this data, you hash this, combine them, and then you verify that the signature of this with this data matches the public key that you saved in the database. So I'll show it in just a minute. First, I decode all things because I ended up encoding everything with base 64. Then I grab the public key that's saved, and then I check the user authentication. So here's a function for authentication. That's the public key from database. That's the client data that I got from this client, and then this is the authenticated data that's provided also by the client, and that's the signature provided by the client. And I decode all these because I sent them all as base 64 encoded, and then I hash this one, the client data JSON, and then I merge it with the authenticated data, and then I just do this. I create the key using the public key, and then I make sure that this signature provided by the client is signed with the private key that is a pair to the public key that I saved. And then once I've done that, I just create HWT with the data and return it. This isn't the best way to do this, but it works for the purposes of this demo. So all that's left to do is look at the client. So on the client side, I'll start here. These are my two buttons. This one, I check for all things that have this attribute, and then I read the rest of the attributes on it, and I use that to execute the function. So when you click it, it will just call registration start, which calls .create that I showed earlier, and then this just sends it to the server. Same thing for login. This will call the get function with all the data provided here, and then this will send it to the server. So let's look at these functions. And so these come from the attributes they were server-side rendered in, and I have a challenge that I convert to a uint array, and then this is data about my server, and this is data about the user. It just includes the user ID, the username, and the display name. And I pass this data to the credentials.create, and this returns back credentials. And here credentials has client data JSON, and then I use the get public key method and the get public key algorithm method to return that to the server. These are the only things I actually need from the credentials.create method. And the reason for all this mess around with the base 64 encoding is that JSON.stringify doesn't work on this response object yet. It works on Firefox because the API is still experimental, but it's hard to use for everything else. So I just base 64 encode these for now. And once they fix it, it'll be so much easier. You'll just encode this response and it'll give you everything you need. I save this data and then I post it to the server, and then registration is complete. For authentication, which is signing in, the only thing you need is the challenge, so I give that, and then it'll encrypt some data using the private key that's saved on the device. And this data is returned here, so it returns me the client data JSON. It returns me the authenticated data. That's for data that was signed. And then the signature is for the SHA-256 of this appended to this one. And that's the signature for that data. And then this is just the user ID that I sent to the server. So I base64 encode all that, and I'll show this encode function in a little bit. And then I send that, and I follow any redirects that come through. But yeah, this ends up being super simple. It just takes a while to deal with this encoding, and I'll just show this encoding function. So this just takes the byte array, converts it to a uint array, converts it to a string, and then base64 encodes it. A lot of hoops to jump through, but it's the best way I found right now, and the easiest way to decode on the server side. Yeah, that's pretty much it. I think passkeys are very cool. I really do think they are the future. It was a pain to implement it, and the APIs feel a little bit iffy. Being able to sign in without depending on a third party and without a password, I think is huge for users. I think that it'll be game changing. I don't like that the safest option right now is just to trust Google, and there's obviously more risks that come with that. So I'm really happy this is being implemented, and I'll definitely be using this in projects going forward. Thank you.